Let's look at the proof to how effective resistance is calculated in a series circuit. Let's recall that in a series circuit, the current is the same. So the current going through R1, R2, and R3, if the current is I, it's going to be I throughout. Now we also know that in a series circuit, the EMF is equals to the sum of the potential difference across it. So V equals to V1 plus V2 plus V3. And because V equals to V1 plus V2, V equals to IR, therefore I can rewrite everything in terms of IR, where I is the same current throughout, and R1, R2, and R3 will represent the three other resistance of the resistor. Now, since current is I throughout, we know we can cancel it on both sides of the equation, and therefore this leaves us with R equals to R1 plus R2 plus R3. Therefore, to get the effective resistance of a circuit, we simply just add up the resistance of R1, R2, and R3. Let's look at the proof to how the formula for finding the effective resistance of resistors in parallel is obtained. Recall that current going through a junction, which is a parallel junction, will have to split between I1, I2, and I3. However, the potential difference across a parallel circuit is the same. So V is the same for R3, R2, and R1. So the potential difference is the same. For a circuit in parallel, the potential difference is the same. We know that I equals to I1 plus I2 plus I3, and I equals to V over R. Since V is the same, V over R equals to V over R1 plus V over R2 plus V over R3 for this part. And since V is the same, we can cancel away this, and this will leave us with the equation 1 over R1 plus 1 over R2 plus 1 over R3, where R is the effective resistance. Let me reiterate what is the meaning of effective resistance again. Effective resistance is a particular resistance to represent the resistance of the whole circuit. Therefore, if I need a resistor to replace all this resistance over here in this network, subsequently in the series part as well, if I need a resistor that can just replace all these three resistors over here on the left side, what value of this resistance is, and therefore that's how we calculate. So this is the proof for resistors in parallel. The formula is given as 1 over R equals to 1 over R1 plus 1 over R2 plus 1 over R3.